All right, it's all about learning targets this year. I'm supposed to tell you what you need to know by the end of the lesson. So, your learning target today is going to be to identify cofunctions. Brand new word for you. Identify cofunctions know what the relationship is between cofunctions. Okay. And then to solve problems with cofunctions. All right. So, it's all about cofunctions today. You haven't heard me use the phrase cofunctions, but you're going to all day today. What happens with students is they get cofunctions confused with reciprocal functions. Because we spent a whole chapter flipping functions over and making that new function. You did really well in the test with that. So let's quickly review reciprocal functions, then we're going to talk cofunctions. So, reciprocal. So sine's reciprocal function is what? When you flip the sine ratio over, which function are you getting? Cosecant, the one that starts with a C. Are those two ratios equal to each other? No, they're reciprocals of each other. But you have to be standing on the same angle to get the reciprocal. All right? Cosine. Flip it over, you get secant. They're not equal, they're reciprocals. And then our last pair, tangent and cotangent. Okay. Now, I'm going to write all these names out the long way, and we're going to find cofunctions. Okay, we have sine, cosine, tangent, cosecant, secant, and cotangent. Now I want to write down the word cofunction. It's one word. So they're paired up where you have a function name with the word co. So I see sine. What do you think sine's cofunction is? Cosine. See how it's sine with a co in front of it? So sine's cofunction is cosine. Do you see any other cofunctions here? Secant, cosecant. Those are cofunctions. So those two are going to be paired up. And then Tangent and cotangent, they're still paired up. So the only pair that didn't change was this pair. Tangent and cotangent are reciprocal functions, and they're also cofunctions. But notice our cofunctions here are not the same as here. So now you've got them paired up. Which ones are paired together? Now what does it mean to be cofunctions? That's the whole big idea. So we're going to do a little theorem discovery to see, well, what makes them cofunctions? What's the big idea behind them? So our theorem discovery, what's the big relationship between cofunctions is going to be found in our theorem discovery. So we'll look at a numbered example with actual values and come up with it. Let's take our 3, 4, 5 right triangle. And we're going to look at the cofunction values. So let's stand on A, and let's do the sine of A. Actually, I'm going to have you run through all of these. Sine, all from A. Okay, go ahead and fill in all 6 ratios real quick. Standing from A. Oh, do we remember these? Oh, maybe I better review. Here's me thinking you're going to remember everything. Okay, we're no longer on the coordinate plane, so that x, y, and r isn't working for us. So we're really back to our SOHCAHTOA definitions. I don't know if I need to write them down again or not. Sine is what 2 sides again? If it's so, opposite over hypotenuse. So if I'm standing on A, what side is opposite? 3 over 5. Do I need to write down SOHCAHTOA again? Yes or no? Okay. So still standing on A. Cosine is ca, that's adjacent over hypotenuse. And then tangent is toa, so that's our opposite over adjacent. And then we take the reciprocal of all those to get our new ones. Okay. Still haven't tied in cofunctions yet. So we got 5/3, 5/4, and 4/3. Okay. Now I want you to move over to B and do all 6 ratios from B. Go ahead and you do them this time. You can practice your SOHCAHTOA on your own. Got them? Casey, you want to run through them, please? 4/5, 3/5, 4/3, 5/4, 5/3, 3/4. Okay. Now we want to look at cofunctions, but one from this column and one from this column. So if I look at sine, what's sine's cofunction again? Cosine. I see sine of A is 3/5. What's the cosine at the other angle? 3/5. They're coming out the same. Those cofunctions are coming out equal when I'm standing on opposite angles of the right triangle. What's cosine's cofunction? Sine. Oh, look at what happens here. They are equal when one's on A and one's on B. What's tangent's cofunction? Oh, look it. If I'm on A and one's on B, they're equal. So we're pairing up cofunctions, and I can go down to the cotangent here, matches back to the tangent here. As long as one's on A and one's on B, looks like they're coming out equal. Cosecant's cofunction is secant. Oh, look at those, came out equal. And these came out equal. Okay, so our big theorem is that cofunctions are equal, but only if I'm taking one from angle A and one from angle B. All right? If I'm in a right triangle, what's the relationship for A and B all the time? As a pair, what would you call these angles? What do these two angles add up to? 90 degrees, right? What do we call angles that add up to 90 degrees? What are the first two letters in complementary? Co. All right, that's how it's all connected. If your two angles are complementary, then cofunctions are equal. That's our big theorem. There it is. So, cofunctions are equal only if the two angles are complementary. So cofunctions are equal only when the two angles are complementary. So that's it in words. So if angle A and angle B are complementary, then three things happen. Sine ratio will equal the cosine ratio. But notice the A and the B. It's not the same angle. They have to be complementary. Sine will equal the cosine ratio, same fraction, if those two angles are complementary. Because that just puts you on opposite sides of the right triangle. All right? That's part one. Secant and cosecant will be equal if your two angles are complementary. And then the third part is tangent and cotangent. Tangent will equal cotangent only when the angles are complementary. So do you think you got a good grasp of what the big relationship is for cofunctions? Did I make that clear, do you think? We'll find out here in a minute. Okay, let's see if you can apply it. Write the cofunction. We'll start easy. I'm going to give you the sine of 25 degrees. I have no idea what the ratio is. I don't care. I just want the cofunction. The cofunction has to have a function and an angle. So what's going to have the exact same value as the sine of 25 degrees? First of all, what function is it? Cosine. Do I keep the 25-degree angle? What did I just tell you had to be true about the angles? What had to be true here for these to come out equal? Complementary. So if one's 25 degrees, what's the other one going to be? 90 minus 25, 65. If you were to type those in your calculator, sine of 25 degrees, hit enter. Cosine of 65 degrees, hit enter. You would get the same decimal showing up because it's the same ratio. Try this one. How about the tangent of 3a degrees? I need a function and an angle. So tangent's cofunction is? Cotangent. That part's easy. 1 point for you. How do I figure out what angle to put here? Right, 90 minus, it's the exact same thing we did with the number. Just here I could actually combine and subtract 90 minus 25. Here I just got to write 90 minus 3a. How about, what is going to be the cofunction for cosecant of a minus 10 degrees? So we need a function and an angle. Cofunctions. So first of all, what is cosecant cofunction? Secant, that's the easy part, right? What angle are you going to put here? You think 80 minus a. You think
98 minus 900.
Say again?
Distributed. No. Never mind.
Caitlin was close. You said what? 80. I'm going to write it down. Don't write it down because it's close. You said 80 minus a. 80 minus a. Let's add back. I agree the a's will cancel out, but here I've got a negative 10 and then 80. What's that going to give me? 70. So I don't want it to be 70. I want it to add up to 90. So what number really has to be here? 100. Because then when I subtract 10 from it, that is going to give me the 90. So you can think about it logically, thinking, okay, I've got to cancel out my a and end up with 90 when I add a negative 10. So that's 100 minus a. Or we could just do 90 minus this angle, because that's the same thing we did. We did 90 minus 25, 90 minus 3a. But if I go 90 minus, you have to distribute that minus, and that's where you get the 90 minus a plus 10, which gives you the 100 minus a. So whatever way, you can do it mathematically, or you can just think about it logically. Your choice. When you add back, you better get 90, because the two angles have to be complementary. Good there? Turn the page. Example 2. Solve for theta. Cosine of 2 theta plus 3. That ratio, whatever it is coming out equal to the sine of theta. You might, because you got to solve for theta. You have no choice. All right. You can put an X. I don't care. You can change your notes to X's. It means nothing to me. All right. First of all, You see the two functions. What kind of functions are cosine and sine? They are cofunctions. And I see that they are equal. When are cofunctions equal? When the angles add up to 90. So that's what you got to do first. You got to identify these as cofunctions. So that means the angles add up to 90. So I can throw away the cosine, throw away the sine. I know the relationship in these two angles. 2 theta plus 3 added to theta better give me 90, because that's the only time sine and cosine are going to come out equal, like the problem is saying. And now it's just simple algebra. So 3 theta equals, subtract 3, I get 87. Divide by 3. 29. Okay. Good. Sine of theta plus 6 is 1 over cosecant of 2 theta plus 4. Well, I have a sine and I've got a 1 over cosecant. Sine and cosecant are not cofunctions. But this, see this as 1 over cosecant. This is a Halloween costume over here. Who's hiding in the Halloween costume? Who? It is sine. 1 over cosecant. That's like cosecant's reciprocal. This is sine with a Halloween costume on. See this as sine of that angle. Okay, now I've got a sine ratio equaling a sine ratio. Well, what does that mean about my two angles if the two sines are coming out equal? They're at the same angle. You're standing at the same angle on the triangle for the two sines to come out the same. So now I know that this angle has to equal that angle. They don't add up to a magic number because I don't have cofunctions. I've got the same function, which makes the angles the same. And then it's just simple algebra. Okay, I'm on the last page. One more theorem discovery. We already did this in the last chapter. As an angle measure increases, in a right triangle, what happens to the size of each trig ratio? So the easiest way to see this is to put your right triangle on the coordinate plane. And see the unit circle, 1 to 1. So I'm going to start with a right triangle with a small angle. Then I'm going to increase that angle. So I'm going to take that hypotenuse, increase the angle by making it go up. So I make a new right triangle. So the pink angle has a small angle, the green one's got a much bigger angle. So you can see now we're going to look at what happens to our ratios. And it's going to be easier to see it as our x, y, and r definitions. X, y, r is a 1, because we got it on the unit circle. And then you've got your green x, and your green y, and your 1. Put an A there. So, as the measure of angle A increases, let's start with sine. Okay, which letter is giving me sine again? X or Y? Y. So, when A is small, you see the Y leg is small. As the angle gets bigger, what's happening to that Y leg? It's getting bigger, which is going to make the sine ratio increase. What's going to happen to cosine? Knowing that cosine is the X leg of my triangle. So as the angle is small, I can see the X leg is quite long. But as it gets bigger, what happens to the X leg? It gets smaller. So cosine is going to decrease as the angle increases because that bottom leg is shrinking in. Tangent. So remember, tangent is the y divided by the x. So I've got a small y divided by a big X. So small top number, big bottom number. Is my overall decimal going to be big or small? Small divided by big. Small. As it gets bigger, the Y leg is getting bigger, so that's my numerator. Bigger divided by smaller is going, what's happening here? Anybody see it? Increase. So two of the functions increase as the angle increases, the cosine decreases, and then the reciprocals would do the opposite, but we just usually focus on these three. So that means cosecant would get smaller, secant would get bigger, and cotangent would get smaller. But we usually just focus on these three. One example for this. Without a calculator, true or false? The cosine of 30 degrees is bigger than the cosine of 40 degrees. So you just got to think, when is the X leg longer? Is it longer when it's down at 30 or is it longer when it's at 40? The X leg. Where is it longer? 30. So is the statement true to say the cosine of 30 is going to be bigger than the cosine of 40? Yep. Cosine of 28 is smaller than the sine of 28. There are actually a couple ways to think of this one. It's easy to, when it's the same on both sides, to compare. It's a little bit tougher when there's two different functions. But because these are co-functions, I can rewrite the other one as its equivalent. So let's go back to, what's sine's co-function again? Cosine. What's going to have the exact same ratio as the sine of 28? The cosine of what number? What do we got to do to figure the angle out? 90 minus 28 is 62. So now, because those are equivalent, I'm switching this out for something that's equivalent to it. Is the cosine of 28 smaller than the cosine of 62? Think about the x-leg. Cosine of 28 longer here, shorter here. So is cosine of 28 smaller? No. So that was false. Okay, page 69. All to 32 even. Odd, all, and even. I don't know why I did that so obnoxiously.